11. You guys are on text page 174 through notebook page 285. And we're doing lesson 4.3 again. So we're going to redo it because we didn't have a video for it. First off, we're going to talk about y equals x squared. Y equals x squared, we consider it our standard equation for a parabola, okay? That parabola shape, the vertex will always be at the origin. And when we draw a parabola, we go over one and up one. The reason we go up one is because we're squaring by the amount we go over. So if I decide to go over positive 1, I square positive 1 and I get positive 1. So my next coordinate is 1, 1. So you know what? I'll write the coordinates out here. 0, 0. That's our vertex. I've gone in the positive direction 1, and when I squared that number, that is 1. So there's another point for this equation. I'll put it right here. What if I were to go in the negative direction 1? What would my y coordinate be? Positive 1. Negative 1 times negative 1 is positive 1. So there's another coordinate. We go negative 1 and up 1. Okay? Let's go in the positive direction 2. If I take 2, the reason we square it, guys, is because I'm taking this number 2 here, and I'm plugging it in for x. So when I put 2 in for x, it becomes 2 squared. Y is equal to 2 squared. What is 2 squared? 4, that's right. So when I go in the positive direction 2, my y coordinate's 4, so I go 1, 2, and up 4. There's another point on the graph. If I go in the negative direction 2, what's my y coordinate? 4. Negative 2 squared is still 4. So another coordinate on this graph is negative 2 and 4. And then we can continue this pattern because this is a never-ending graph technically. What if I decide to go in the positive direction of 5? What would my next y coordinate be? 25, right? And that, now guys, we've got to remember that is for this specific equation right here. Y is equal to x squared. That's when we don't, a is 1, and we don't have a value for h or k. It's just y equals x squared. And I want to do one extra one. What if I went in the negative direction 12? I decided to go negative direction 12. Positive 144, that's right. We just square that. So it becomes very easy to draw our standard parabola here, okay? Connect the dots. I know I say this is easy, but, oh, actually, that was pretty good. There you go. So there is our y equals x squared. Now, first of all, we're going to talk about a. I'm going to talk about simply when a is positive and when a is negative. Okay? So right now, what is my a value in front of our x squared? 1. Is it positive or negative? It's positive. So because this is positive, this parabola opens upwards. The u is going upwards like this. This is a positive a value. If my a value, say our a value, is negative, so we have y equals negative ax squared. We don't have to know what a is right now. We just have to know if it's positive or negative. If a is negative, which way will this parabola open, Tom? Down. It'll go downward. So in other words, we'll have some parabola going like this. It's going downward somewhere. Now, these are just examples. We're going to do an actual one. So since we already know how to draw the parabola when it's y equals positive 1 x squared, we're going to try y equals negative x squared. Okay? All this means is we're going to have a mirror image of this parabola we've already drawn. I'll do it in blue. Our vertex is still going to be at the origin. The only difference is we're going to be opening downward. So I can pretty much copy the points that I've already drawn, just reflect them on the x-axis. So when I go to the right one, instead of going up one, which direction do I go? Down. I go down one. I go left one, so negative 1 direction. Which way do I go? Down 1. Okay? Same with our 2 and 4. We go down 2 and down 4. And I'm going to talk about why this works. So if you notice, this parabola is y is equal to negative x squared. In other words, a is negative. And that parabola there is y equals x squared. In other words, a is positive. Okay? So, first of all, if a is positive, we open upwards. A is negative, we open downwards. And the way, or the reason this works, I'm going to put some coordinates out for this. Let's say we plugged in positive 1. I plug positive 1 in for my x. First thing I do is exponents according to BEDMAS. So I do 1 squared, what do I get? And then times this negative, negative 1. So I go to the right one, I go down 1. There's one of our coordinates. What if I went in the negative direction 1? Negative 1 squared is positive 1 times that negative, negative 1 again. You guys see how these coordinates are just a mirror image of the one above? Does that make sense? Okay. So, just to repeat, we always start at our origin if we have no other values. Okay. So our vertex is at the origin. If I go in the positive direction, 1 unit, that means I have to square. So however far I go along my x-axis, I have to square that amount. So like I said, we went in the positive direction 1. So what is 1 squared? 1. So I go up 1 from there. And there's our coordinate, 1 and 1. If I were to go, let's say, over 4, how would I know where to put my y-coordinate? 4 squared. What would 4 squared be? 16. So I would go over 4, and then from this point up, 16 units. So I'd have some unit that is at 4, 16, somewhere up there. Okay? If I go in the negative direction, 2, if I square negative 2, what do I get? 4. So I go back 2, up 4, and my coordinate is negative 2, 4. Exactly what I have here. Now remember, this is just for our standard one, y equals x squared. We're going to get into other parabolas that are different, okay? So that's the idea, to draw a standard parabola. You must know how to do that. Over 1, square it. So that's our first rule of A. When A is positive, it opens upwards. When A is negative, it opens downwards. Now there's another rule with A we're going to deal with down here. Our next rule with A, y equals, and remember we're going to do our standard again. It's always good to have that standard. Okay, our next rule of A is when A is a number other than 1. So above we were dealing with when A was just 1 and when it was positive or negative. The positive and negative rules will still apply, but our numbers have changed. First thing we're going to talk about is when A is greater than 1, the parabola becomes thinner. Okay, so when A is greater than 1, our parabola is thinner. So what that means is some value greater than 1, let's say we have 5, 6, 7, doesn't really matter. This is just an example. Our parabola is going to look more like this. Vertex still at the origin, but it's going to be thinner than our original, which is in black. Okay? It is a thinner parabola. If we have A is greater than 0, but less than 1, so we're saying between 0 and 1, so some decimal, our parabola is going to get wider. Okay? So that could be a fraction 1 over 3, could be 0.7, anything like that. What that means is our vertex will still be here, but our parabola is going to be something like this, wider than what our original one looks like. And once again, our original is in black there. Okay? Okay, so I have 2 new examples on the board. Oh, I did them in blue for some reason. Because we're talking about A, I want to do it in red, so it's color-coded to what we're used to. 2 and 1/2. So in this value, first of all, is A less than 1 or greater than 1? Okay, so this is A is greater than 1. Therefore, already we know what this parabola probably going to look like. Thinner. It's going to be thinner than our original. Well, I'm going to show how to actually find the coordinates for this. Now, normally, our origin, when x is the value of 0, I plug 0 in for this x squared. What's 0 squared? Times 2? 0. Okay? So my y value is 0. So I know when I go to draw this parabola, my very first coordinate, 0 and 0, right on the origin, just like we had before. Nice. Okay, what about when x is 1? I substitute 1 in for that x. What is 1 squared? 1. And then when I multiply that by 2, I get 2. If you guys notice from our coordinates above, that's different. We're used to going over 1, up 1. In this instance, we're going over 1 and up 2. So our next coordinate is 1 and 2. Same idea if we go the other way. What if we use negative 1? I put negative 1 in for my x. What is negative 1 squared? Times 2? 2. My next coordinate is negative 1 and 2. So I go negative 1, 2. You can already tell that this parabola is probably going to be thinner. Let's try another one. We go to the right 2. I plug 2 in for x squared. What is 2 squared? Times 2? 8. So, over 2, up 8. Don't even have that on the graph. Say it somewhere here. And same idea here. Negative 2, what does our pattern say this is going to be? 8. That's right. It's going to be 8. They're a mirror image on the y-axis right now. So we go over 2, up 8. So, kindergarten, connect the dots. And is this thinner or wider? Thank goodness you know the difference. Okay. This is a thinner parabola. And in fact, the greater A becomes, so if we go 2, 3, 4, 100, the thinner the parabola is going to become. This parabola will become more and more thinner. I don't know if that was proper grammar, but let's get it up here. Narrower, that's the word. It'll become more and more narrow the greater that value becomes. The next one we're going to deal with is when our value, A, is a half. So is that greater than 1 or less than 1? So this is our A when it's between 0 and 1, like we said. So what does that mean this parabola is going to be? Wider. Very good. So, very simple. Our very first coordinate, when x is 0, we plug 0 in. What's 0 squared? Times a half? Still 0. So, our very first coordinate, hey, right there on the origin. Hey. Okay, what about when x is 1? We plug 1 in for x. What is 1 squared? Times a half. Times a half. Anyone know? What is it? 0.5. Or otherwise known as a half. So what that means, now this is a little harder to do, when we go over 1, instead of going up 1, we're only going up 0.5 or a half. Let's do it with negative 1. X is negative 1. Negative 1 squared is 1 times a half, 0.5, or otherwise known as a half once again. So I go to the left 1, and I don't go up 1, I only go up a half in this instant. If x is 2, I put 2 in for my x. What is 2 squared? Times a half. 2. So I go over 2, up 2. Same idea with negative 2 from our pattern. What's our y value going to be? 2. Oh, what the? So I go negative 2 squared is 4. 4 times a half is 2. So if we look at that, I can even go over a little more. I'm going to quickly do this in the interest of time. So because we have the ability to extend it, I'm going to say I go over 4. 4 squared is 16, so I plug it in there. 16 times 2, times a half is 8. And the same idea is happening with negative 4. So when I go over 4, I actually go up 8, which is somewhere here, and back 4 somewhere here. If you guys notice, this parabola is What in comparison to our normal one? Wider. Very good.